Usually it's 6 months, and I make it private instead of removing it, and so I can share the password with the attendees once it becomes private. And I make it private instead of removing it. That was feedback from the recording. Yes, so I'll leave it there for at least 6 months, and then usually I try to make it private once the next class starts. Although the content is similar. I mean, I improve the classes over time. So this class in particular is kind of unique, the intermediate one, because it's not offered very often, and so this is more custom than the fundamentals ones, because I try to incorporate in the class some themes and topics that are relevant to you and your practice. So so I can leave them, at least 6 months to answer your question. All right. So here's a way to know whether something is a system family or a loadable family. A component family, it's loaded into the project as an RFA. You can load them from the out-of-the-box library, or you can load it from the cloud library. Examples of RFAs are doors, windows, casework, furniture, planting, etc. And then there's another type of family that is called in-place families. These are families that are unique, that are created on the fly. They report a unique condition in the project. They are not intended to be used as a repetitive component inside a project. It's like building a family on the fly. It gives you access to the family editor commands or functionalities within the project environment. All right, quick overview on how to get started with families. You pick the right templates. Not all the categories are represented in the library of templates, but the majority is. If you need to start a family that you don't see a template with, so you start with maybe just the generic model, and then inside the generic model, you can change the category. So let me show you here. I'm going to start a new family, and let's say I want not all the categories are represented as templates. I don't know, for example, I don't know, the nursing device. There's no nursing device template here. And so if I wanted to create a nursing device, I would start with the generic model. And then from the family category and parameters button, you can pick a different category here. And these are all the categories that you can swap from. These are partial lists. I'm going to do the full list. Here are the nurse and call devices, and you can create a new family using, you can swap it, and then that's going to create or associate the parameters that are unique to that category. I'm going to close this. So that's those are the 3 types of families. So this is a Revit 101. The family editor opens up a different type of user interface, and most importantly, it display a solid editor type of a solid editor. Extrusion, blends, revolve, sweep, and sweep blends are ways in which you can create almost anything. Let me jump into this other slide here. This is the an extrusion is a profile that's perpendicular, orthogonal to the plane of the profile. A solid blend is a extrusion between two different profiles. And so when you create this profile, you can sketch them or you can load them as a profile family. You can create a solid revolve by defining the axis of revolution and the profile shape and the angle of revolve from 0 to 360. A solid sweep, which is frequently used to generate architectural trims, whether they are interior trims or exterior trims. Solid sweep is usually the most effective way of creating those. So you start by building a profile, either by sketch. By sketch means that you build it on the fly, on spot, or you build a profile that it's a family profile and load it into the family as a, which make it available as an option for the solid sweep. You have to define a path. The path can be two-dimensional or three-dimensional. And it will follow the path perpendicular to it. And then you have a solid swept blend, which isn't used very often. But this is a way to create an extrusion between two different profiles along a path. So the same set of two solid editors are available to you via the void option, void extrusions, void blends, void revolves, and void sweeps and sweep blends. And a void is the opposite of a solid. It's intended, a void can only exist if it intersects a solid. And so you must intersect a void with a solid in order to carve that information. And yeah, those are the solid tools available in Revit. Let me launch Revit again. I closed it by mistake. Let's return to the recipe of families. All right, this is the recipe how to create a fully parametric family. Select the appropriate template. And then you build the reference planes. The reference planes act as a framework for the family. It's like the skeleton of a family. And it provide working surfaces that you can snap geometry to. These reference planes have a positive and a negative side. It all depends on how you create them. If you create the reference plane from left to right, the positive side is going to be looking up. Always follow the right hand rule in order to understand how the positive side of the reference plane work. And that's important because when you define extrusions, you're going to define either a positive or a negative extrusion, and that's going to be directly it's going to be directly connected to the orientation of the working plane. And the orientation of the working plane depends on how you create it. If it was counterclockwise or counterclockwise, it does matter as far as the direction of the extrusions. Reference plane have also a property that make them strong or weak. Let me show you that in Revit. I'm going to start and I'm going to open this file again. And so while that upgrades, let's also remember that our reference plane, it's visible to you as a working plane if you name it. So if you don't give a name, it won't be an available choice in the drop-down list of working planes that you can use for hosting geometry or hosting sketch lines. So naming a working reference planes is always a good practice. The other thing is you see that parameter that is called isReference, and it says whether it's weak or strong or a named reference. That's the part I want to highlight here. This is a Revit project, and I'm going to build a wall. In this wall, I'm going to add a door. And when this door, you see when you click, when you select or when you dimension a door, I want to dimension it from here to here to there. When I'm in the process of dimensioning, notice how the family displays this reference plane. Like there's a reference plane right at the center of it. Let me hide this floor because that's disturbing. Hide in view element. All right. So when I am dimensioning an element, notice that when you pre-highlight a door, you find that blue line that pre-highlights, it's a strong reference. So a strong reference allow the family to build working planes that can be used for dimensioning or for alignment purposes. For example, I can also use that line for alignments. I can align the door with that reference plane. And so the internal reference plane inside a family define whether a family is strong, whether a reference plane is strong or not. When a reference plane is set to be not reference, then it loses this behavior. You can't highlight these reference plane or these working planes in the project context. And so when we are in the middle of creating a new family, and I'm just going to create a new family using the new family. Using the, I'm just going to do the generic model one. So this is a, and I create a new reference plane. Notice that the default value is weak reference. But you have strong reference and you have weak references, and then you have left, right, center. So all the everything that is under strong, under the weak reference, it's these are name references, and by default, name references are strong. So if these is the back of the building, if the back of a family, and you want it to be a strong reference, you can just pre-select a named orientation. Like I could call this back, and just by virtue of selecting back, it means that it's a strong reference plane. The other option is, say, weak reference. A weak reference only display in the project if you use the tab key. It means like in the order of pre-selection, it's in between the not reference and the strong reference. So when you're in the process of placing dimensions, for example, and you don't want to define a reference plane as a strong reference, but you want to give the option to the user to use it if they want to, then the user has to click the tab key, and then that is going to pre-highlight in the project context. And then if I set this to not reference, this is not going to have any impact in the project. So it will not be visible. You wouldn't be able to access it at all. So when we place these reference planes, let's remember that when we place reference planes, we need to define what kind of reference they are, whether it's a strong, weak, or not a reference. And if it's a strong one, Revit gives you with a list of predefined names you can pick from. All right, the other is these reference planes also have a checkbox that says origin. You can have one vertical plane as an origin and then horizontal plane as an origin. An intersection of these two defines the insertion point of the family. You can change that. Like if I want the back of a family to be the origin, just select it. This intersection becomes the new origin, and then this one is disabled. So the program is built to recognize only one vertical and one horizontal as a origin. And usually the reference planes that define the origin are pinned so that they cannot be moved by mistake. The template already provides you with that.
And this is all in plan, right?
In plan, yes, but they are also visible in elevation. So if I go to a front elevation and hit the tab key, this is the origin. This is a horizontal this is a horizontal. I think I take that back. There are three planes, right? This plane, which is the horizontal plane, it's an origin, but you see how it says it's not a reference because it's redundant with the reference plane. So there are there's the level here, and then there's this reference plane. And so these reference planes define the origin, but it's not a reference because we already have the level, and that level acts as a reference. But then we have these as well, that it's origin. So I rephrase that. There are three reference planes that defines the origin. Thanks for the question. Okay, so when we are in the process of thinking of creating a family, think about what are the shape, what are the phases of these family that need to be parametric, and certainly use if this family needs to increase in size in certain directions, which is typical of some type of furniture or like tables or countertops, then let's make sure that we add the reference planes as needed. All right, so reference planes is the framework of the family. give it a name to be able to display them as a working plane. And then we define the behaviors. The behaviors are how the family is going to flex. So in order to create a behavior, we use labels, and a label can only be created when you place dimensions. And so we place dimensions between the reference planes in order to define behaviors, or to provide a parametric behavior. That's what a length parameter means. A length parameter allow me to create a label that is parametric. And so we create a when we create a parameter, we associate the parameter with a dimension. And so after we make that connection, then the parameter is listed as an instance or a type parameter inside the family types. And then this family type information travels with the project, where the user can have access via instance or the type properties. It's important to flex the family. Flex the family means testing the dimensional values of the parameters to make sure that the object is behaving as you expect it to be. You have to flex the family at various points in the family creation. All right, let me jump into Revit and show you that. So you don't have to do this. I'm just reinforcing. This is a way to reinforce my PowerPoint. I create the skeleton of the family, and then I created these reference planes. I'm going to make them strong references using the predefined list of strong lines. So this is the left, this is the right, this is the back, and then this is the front. And then I establish relationship. Like I want this is going to be like a small cube or like a coffee table, and I want the origin to be always center relative to I want the geometry to be always in its geometrical center. So I create these equalized relationships that no matter what the dimension of the distance between this reference plane is, the origin is always going to remain center to this table. So now I can add a parameter. To create a parameter, I have to create first a dimension. This is going to be like the table width. And to create a new parameter, you hit the label tool, which opens the parameter properties dialog box. You give it a name, width. There is, as a good practice, some people say the parameters should always be listed in lower caps. That's at least a recommendation from structural engineers and computer scientists. But again, this is not written in stone. My preference is to write them all in small caps. So this is like the width. Define whether it's a type or an instance property, and do the same in the opposite direction.
So what's the difference between type and instance?
A type parameter is it's a parameter that is common across all the elements of the same type. So if you change it, if you change a type parameter, all the elements belonging to that type are going to change that property. An example, You have a door. The door is 3 by 3 by 7, 3 foot wide by 7 height. But if I access the type property, wait 1 second. My Alexa is going crazy. I'm okay now. So if you change the type property, you change it for all the elements. Is the equivalent, if you use AutoCAD, is equivalent of changing a block and then reinsert it into an AutoCAD file, and then all the blocks get repopulated. So that's the same with the type property. You change a dimension for a type, and it disperses across all the elements that are already placed in the project. Instance parameters are unique to an element, and that means that it's visible in the properties of the element, and is unique to an object. You can, if you make it an instance, only that element will change in the project when you change the parameter. And again, when you build families, you have to decide how the user interaction is going to be. Do you want them to have multiple types? And create a type for every parameter change? Or do you want the user to have the ability to change every element and define every element with a different value? So in the first example, in the type example, you're going to create multiple types for different parameter values. In the second option, you only build one family, and then that single family give the users the ability to change parameters at an instance one by one instead of global changes. This means global changes per type. This means individual changes. All right, so this is I'm creating the parameters. This is depth. Notice how, because I selected a dimension, the length is automatically populated and it's placed under the group dimensions. And so now that I created 2 parameters, those parameters are going to be listed under the parameter in the family types. So I can change this to 4. And this is the process of flexing the family. Flex the family means you apply different parameter values to the family to make sure that it behaves as expected. So it is behaving as expected. The order of the parameters in the family type dialog box can be overwritten. Like you can select a parameter here and move it up or down. And by default, these parameters are stacked one on top of each other alphabetically, but you can override them. And so this was a new feature maybe 4 or 5 years ago, the ability to sort parameters, customize how the parameters are presented in the family type dialog box. And then the other thing is that there are some parameters that are already there. For example, this constant default elevation, this is called a family parameter or a system family parameter because it's given to you via the template. And so there are some parameters that cannot be deleted. System family parameters cannot be deleted. You see how the depth and the width, which I created, you can delete it using the delete parameter, but with the system family parameters, you can't. They are fixed. They're essential part of the category definition. All right, so I have two parameters here that are flexing as needed. Let's continue with the recipe. So step number 6, you can add to dimensional, is that right? Let me go back. Yeah, flex the family. That was step number 6. Create model and symbolic line work. So the symbolic line work is two-dimensional lines that you add on top of the 3D geometry just to describe a feature of a family. This is the case if you want to have the family in different resolutions. Like if you want to have a version of the family that only only displays in 2D, then you can do it as well. Like, and that's usually, you know, if you are preparing, for example, desk layouts in a floor plan, maybe you don't need to add 3-dimensional families, and you can do your studies more efficiently with less impact in the performance using 2-dimensional family. And 2-dimensional family is just a flat line that represents an object. Now, the advantage of using BIM is that you do everything in 3D, but that's not necessarily the case depending on the purpose of your work. And so sometimes there are families that are 2D, sometimes they are in 3D, depending on what is being used for. Remember, what the goals of creating a BIM project state that you can use it for 3D authoring, or you can use it for 2D authoring. And if you just do it for 2D authoring, maybe it makes sense to have a 2-dimensional family. Let's see, in Revit, that translates into adding annotation lines. And again, these lines are only going to show in projection views in the project. So if you they're not going to show in 3D because they are symbolic in nature. I'm going to add, just for fun, this X. And that means that these X are symbolic lines. They're only going to appear in a floor plan in the project. They are not going to appear in a rendering mode. They're not going to appear in 3D. They're only visible here as a reference line in floor plan. Any question? All right, the other thing I wanna show you guys is that when you snap to the reference planes, you don't need to establish align locks. So notice how I'm gonna try to flex this. And notice how this diagonal, because it's snapping to the intersection of 2 reference planes, then it established an automatic lock. And this is a property of snapping to reference planes. There's no need to lock it. Revit create this automatic relationship with intersection of reference planes. So if you want to display them, if you go to visibility graphic inside here and go to annotation categories, you see there's a checkbox that says automatic sketch dimensions. And these are locks. They are literally constraints that Revit creates as a result of snapping to reference planes. You didn't place this. The family editor plays them, and it's telling you that the end of this line, it's locked at 0 distance from this reference plane in X and Y. So I'll go back into the annotation category and disable that. Okay, so this is a step number 6. Step number 7 is to create now the 3D geometry. You can if you snap the geometry to the reference planes, you don't need to lock them. Then you have to assign the 3D geometry to a subcategory. The subcategory is a way to categorize the geometry belonging to that element inside the project. Subcategories can be custom created. Then we create additional parameters as needed, like materials, visibility, formulas, and assign those parameters into the family types. Then you also assign visibility settings, which allow the geometry to be visible in different projection views. So you can set a geometry to display in different projection orientations, front, back, plan. And you can also set the geometry to display at a specific coarse level, detail level, coarse, medium, or fine. So in Revit, this is what I mean here. So now that I have my 3D geometry here, I can create, you know what, I'm gonna, in the elevation, I'm also gonna create a new reference plane. And I'm going to create a new parameter that is called height. And I select it and add a parameter. There's also a type property. And I'm going to predefine the value as 2. And in the floor plan, I will create now the 3D geometry. Create an extrusion. If you snap to reference planes, you don't need to lock geometry. So I'm going to create a rectangle. But you see, if I do this, this is wrong, because this is snapping to the end of the line, of the symbolic line. Is that not correct? So if I wanted to force the geometry to establish a relationship with the reference plane, I need to use the reference plane intersection. So I'm going to type on the fly SI. And choose the intersection. You see that is a reference intersection. And then I'm going to do SI again, SI right here. There's no need to use those locks. In fact, that is overly constrained because you're creating double locks. The ones that the family does automatically, and the ones the user defined locks, which is just clicking those locks. I'm going to leave them on lock, and then I click the green checkbox, and let's see if it flexes. Yep. The other thing, in elevation, in the front elevation, here I will have to force the lock. So the extrusion started with from a sketch line hosted at the reference level. And then if I want this to follow the height, you just grab the handle, snap it, and lock it. There are times where you will have to do that. If I flex this and the height, then it will flex and so forth. So I have a geometry that is flexing. I can also set elements in this geometry to display additional custom parameters. For example, the material. Materials usually, if you ask me, best practice, it's leave the material out of the family. Materials must or should be defined inside the project environment. And why is that? Because the project specifications is going to define what is the final type of material for the building assembles. And those vary from project to project. So for example, you can have a table You don't know what finish is going to be selected by the owner or by the project team. And that table can be, the family can be used across multiple projects. So the material will be defined and specified according to the project specifications. And so it's better to associate materials in the project environment rather than inside the family editor. And the way to add, to make sure that the material is set in the project is to create a material property that is either an instance or a type property. So let's do that. So these, when I select this, when I see this in 3D, this cube has a material that says by category. When it says by category, it's going to inherit the material properties of the object styles in the project associated with generic models. I'm going to go back and change the category of this to furniture because this is a table, like a coffee table. So this is how you change category, furniture. And then I'm going to, now that it's part of the furniture category, you can also assign materials or create a custom materials. That's what you do. You to create to be able to associate materials from the project, build a material parameter inside the family editor. So here, I'm going to add a new parameter. And this one is going to be called table material. And we're going to make it an instance. And what that means is that the user has the ability to select a different material by type. And the type of parameter is material. And it will be grouped automatically under the material and finishes group. So here, okay, click OK here. And notice this is the new material that I created, the new parameter that I created. And then I hit OK. But that's not the end of it. Now I need to associate this solid with that parameter. And this process is called concatenate material parameter. So when you select an object and you want to make sure that the material is hosted by, can be defined by via parameter, you concatenate using these associate toggles. The associate toggles are these little buttons that appear right next to the material. And it's a way to tell the object to be connected, to inherit the properties of a specific parameter. So the value of this parameter called material will be driven by an associate parameter. So click the associate parameter button and select the table material. And now the material of that piece of geometry is driven by this table material. Just as an example, the limited set of materials that it's inside a family, which is less than a project. If I select this as glass, then I did not have to select the project, the geometry in order to assign it the glass. You do it via material parameter. So I'm going to return it to by category. The way you do that is you open the material browser and then you hit this first button here that says parameter and then hit apply, hit OK. Now it's by category. Wherever category this object is at, then that's the material is going to inherit. But the good thing is that these parameters are going to travel into the project, and then in the project you have the ability to select it from the project material list. Any question here about that? Okay, so going back to my recipe, we added additional parameters. I created a custom material parameters. You can also add just no visibility. Those are parameters that enable the visibility of certain aspects of the family. For example, in the case of doors, in the case of doors, sometimes the hardware is visible only in elevation, but it's not visible in plan or in 3D or in a section. And so that's an example where the door handle is added into the family, but then you disable its visibility in certain view orientations. All right, then the last few steps is flex the family all the time. Make sure that the parameter values are working. And then create different types. A types is unique representation of type values. And you give it a name that makes sense. Flex it, load it into the project, make sure that it's working okay inside the project environment, and check it. There needs to be a quality control that happens before this family is distributed for the users or for the project use. All right, so going back to this project, I'm going to close all my views here. I'm going to create a new project. I want to save this. I'm going to call it table box. And then I'm going to load it. I'm going to create a new project just to test it. New project. And the family can be loaded from the family environment, or you can click load family. Here is load into the project and close the family. So this is the box I created. Notice how the symbolic lines only display in 2D. They don't display in 3D. And then when I switch in 3D, this is the table box, and the material parameter can be defined here, where it have access to the project materials, which are the ones that get specified in the project. And this project material has far more materials than the one you have in the family environment. And from here, you can get different materials. You can also create new types from here, or you can define them in the family environment. This is listed under the generic models, because that was, no, I think I say furniture. So on the furniture, I have my table box. You can right click and duplicate it to create new types. Maybe this is 2 by 2, 2 by 3 by 1, which means 2 feet by 3 feet by 1 feet. Then double click the type, and you just change the values. I'm changing type property. So the depth is 1 by 3 by 2. Then you can duplicate this and create new types, and then you can build your entire family of instances. It's probably recommended to do that inside the family editor, not from the project, so that those types are also available to other users in other projects when you save this family in your library components. Okay, that was the recipe of creating a family. Any questions before we do the exercise? Okay, Let me see if there's something else here that works. Yeah, I think I did. I covered everything here. All right, so let's talk about creating a custom curtain panels. And I think I opened this file for you guys last time and show you that when you create a standard wall or a standard curtain wall, this is a regular storefront. These storefronts have the ability to report system panels, and those system panels, when you edit the type properties of this and you look at this curtain panel, notice that there is a, let me open my all right, so this parameter here that says a curtain panel, notice that it has the word system. So a system panel is a system family, meaning that you cannot save the system panel as an external file. But curtain panels can host system panels and component panels. So everything that says system panel here, those are families that cannot be swapped. But then you have all these other families that you can swap it by. You have this glazed panel with spiders and all these different types, different families. And so you can say none, and that is just going to display a trellis, or not. That's odd. It's odd that it's displaying a model. If I say no, this is supposed to not show anything. But maybe that's because this is an old, very old drawing, maybe in a new one. Let me close this. I'm going to create a new project. And I'm going to create a storefront and look at it in 3D and look at the properties that you can do there. So you can change the curtain panel with a system glazed, system solid. So that's a solid panel. And then you can swap it with other like wall types. Like if you say, I want this to display bricks. I don't know why we do that. Or you can do this with like concrete. Like with concrete, it makes sense if you want to do like precast concrete. Sometimes you can use curtain walls to do both the concrete and a representation of the reveals. So if this was a concrete wall, I'm just going to do here a generic 12 inches. And then I disable all the mullions and say no, 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 no to all of it. I'm still going to see the subdivision of the curtain walls, but no panels and no mullions. And this can easily be used as a representation of, like a concrete wall. And you can actually create dimensions and snap to the elevation of that. But anyway, let's undo that. My point here is that curtain panels can be replaced or can be substituted by loadable components. So here's one. There's an empty system panel. Yeah, and this is the one that make it go completely transparent. There's no glass there. But then if you want to do something that is custom, like not provided out of the box, then you have to create a custom curtain panel. And that's what we're going to show you now, how to create a custom curtain wall with an embedded shelf. All right, so let's get started. Open on your any question here. In Revit, let's do this together. Let's gonna create a new family. So open Revit 2023, and in the family portion and the left panel, create a new. And the template we're going to use under the English Imperial is the curtain wall panel. So find the curtain wall panel. Don't use the curtain panel pattern base. That's a different animal. Use the curtain wall panel and then hit open. All right, so this is a way to create a custom. This is the template. The template comes with a pretty fine list of reference planes. And it does have a way to identify what is the exterior of the curtain wall and what is the interior. So the quadrant at the top is the exterior, the bottom half it's the interior. And model accordingly. These letters here are reference letters that are for our reference. They do not translate into the project. And then I'm going to open the notice when you start a new family, Revit automatically opens 4 views: the exterior, the right, a 3D perspective, and a reference plane. All those 4 views are open automatically. And if you want to stack them, just type TW or WT. Yeah, WT. WT is a wall tile. Window tile. And notice, maybe this is a little tip, when you have windows that are tile and you want them in a specific order, like if I want the exterior one to be at this corner, select it, enable this, and then tile WT, and then it moves it right to the very first one. There's a way to rotate them. Select them, WT, then whatever is the active view, it takes the first tile. Now, a 3D view is a perspective view. I don't like to work in perspective. So I'm going to close it. And I'm going to have a exterior. This is like an elevation, the plan, and the left elevation. This is all stacked in 3 viewports. Okay, so I want to create a type of this. I'm going to sketch what I want to do. I want to create a curtain panel. I know there's a building done by a famous architect that display. This is a section view. Actually, let me do this. In elevation, it's a panel. It's a curtain wall that looks like this, but then in elevation, it's something that does like that. And so You define the distance at the middle. This will be a parameter we're going to build. And so the idea that you can have these interlocking custom facades with solid material. We're going to build that from scratch because this doesn't ship with Revit. We'll have to do it. And so the first thing is to define the reference planes. Now, when it comes to curtain walls, I am in the exterior elevation, and I have 4 reference planes that are strong. This is the right, the left. They have a name. They have the top, and it has the bottom one is not as strong because we already have this reference plane, the reference level. So whatever is contained by these 4 reference plane is automatically going to be detected as the size of the panel. So you don't have to put dimensional constraint as far as width, height, and depth. Revit is going to take care of that. The program or curtain walls are built to detect the size or the location of these 4 reference planes. And so never delete them. Just keep, these reference planes came with the software, came with the template, and they are there because they define the outermost boundary of the curtain wall. And so don't delete them. Keep them as they are in that location. And the size of the panel doesn't matter because the ultimate size of the curtain panel will be driven by the host size. That distribution of vertical and horizontal grids, that's a type property in the wall. That's what's going to define the final size of it. But what I want to is to create a panel that has inclined leaves, and so that panel has to be right at this half of it. So I'm going to create a reference plane. I'm just eyeballing. Again, I'm in the exterior elevation, and I'm going to make sure that this is has an equal relationship. So place a running dimension and click the EQ. And no matter what is the size of this, then the half point is always going to be detected by Revit. And so on the left side of the other thing I want to do is that in the right elevation, I want to have a positive offset and a negative offset that's going to have the same value. So I'm going to do 2 reference planes. So you create reference plane on the exterior side and another reference plane on the interior side. And these reference planes need to be offset from the center using the same dimension. And I'm going to call that offset, a parameter called offset. So to do that, I need to create 2 dimensions. One dimension from the center to the exterior, and another dimension from the center to the interior. And these 2 dimensions are going to be associated with a parameter that it's called offsets. And the same offset is going to apply to the negative and to the positive. So you select the dimension, and then you click the label tool to create a new parameter. The label tool, it's this little looks like a calculator with a little star. And I'm going to call this offset. And it's going to be a type property. And the value for that for now is going to be 1 feet. So change that to 1 feet. And the same, apply it again. I'm going to repeat the process on how to create the parameter. I'm in the right elevation, select the dimension, open the parameter, or create a create a new label. Give it the name offset. Hit type parameter, click OK. I'm not going to do it because I already did it. And so for the to associate this dimension with this parameter, you just select the dimension and use this associate with the parameter in this drop down label panel. All right. So if I flex this, the offset should work. Like if I do 6 inches, there you go, 6 inches. So the offset is one of the elements of these two elements. All right, so let's create an extrusion. All right, so I'm going to sketch it first to understand what I'm going to do. So the first thing I'm going to do is to create an extrusion that creates a surface from here to here to here, and that surface is going to extrude from this point to that point. That's the geometry number 1. And then the geometry number 2 is to create a surface from here to here to here. It's going to be hosted by this work plane, and it's going to extrude from this point to that point. And so at the end, I'm going to have these two surfaces with different, with 4 panels and different offsets. And then I'm going to load it, I'm going to give it material and then load that into the project. So an extrusion needs to be a closed, it's based on a profile, and the profile needs to have 4 lines. So I need to do that as well. But I'm going to use the offset tool in order to build the profile. Okay, so the best way to create that profile is on the exterior side. And I need to define my working plane. My first working plane is going to be this guy. It's called the right reference plane. So I need to set that as my working plane. So I go to create, set work plane. And right now is the right elevation. So that's good. I'm in the right work plane. This is it's telling me that the right reference plane is the edit one. And then all I do is to create an extrusion. So the extrusion goes from here. Remember, I'm using reference planes to snap. From here to this reference plane, to that reference plane. And then I'm going to offset this by 1 inch. So you can use the offset tool. The offset tool, it's here. offset by a numerical value of 0, 1. You make a copy of it, and you go towards the interior. So that's it. And then I'm going to create a flat line at the top, another flat line. I'm going to just close the end with horizontal sketch lines, and then clean the geometry. And then hit the green checkbox. I don't know if this is going to flex, and if it doesn't flex, I have to create custom alignments. So I'm going to flex it. You go to flex it. You go to family types. To flex it, you just grab one of these reference planes and just drag it up. And yeah, it's flexing. It's flexing in X, in Y. Let's see if it flexes in this direction. So you just grab the right and move it. Yep. But more importantly, it's flexing in the direction Y. And I didn't have to do any lock. All I need to do is to make sure that it's snapped to the reference line. Now, to make this panel snap to the center, you just select it, grab the handle in the middle, snap it, and lock it. And yeah, this is panel number 1. And any question here? All right, so we're going to do panel 2, and panel 2, I'm going to sketch it. You sketch it. It's going to go from here to here. And it's going to go. It's going to be hosted by this working plane, the right working plane. It's going to be extruded in that direction, and it's going to lock to this reference plane. And then I need to make sure that when it flexes in both directions. All right, to create the, I'm going to close the right one, and I'm going to open the left elevation and tile it, WT. So here is the, let me reverse this, WT. Okay, this is the left elevation, and the same thing. I'm going to create an extrusion hosted by the left reference plane. So you create extrusion from this reference plane to that intersection. To this intersection. And then I'm going to offset by 1 inch, offset by 1 inch. And then I'm going to use horizontal lines hosted by reference planes. And then close the geometry, fillet them. And I do the green checkbox. And let's see if and then notice how I also need in the exterior elevation, grab the extrusion handle and snap it to the reference plane, not the object. You don't want to snap it to the other panel. You want to snap it to the reference plane, and then you lock it. And so let's see if it flexes. I select this reference plane, and it's like an accordion. it's working in X. Let's see, works in Y as well. All right, and the last thing I'm going to do is to define the material for both panels. I'm going to select this panel, both panels actually. And in the parameter called material, where it says now by category, I'm going to toggle the associate button and create a new parameter on the fly called panel material. And then I go okay here. Hit okay. And now this material won't be defined inside the family. It will be defined in the project. One more time to flex. So I'm going to switch to a 3D view here. So open the view, default 3D view. This is the family. And if you grab the top one, it should be flex. Notice how it's flexing as is expected. When I change the width, it's changing as well. And then if I change the offset, let's make it 6 inches. Oh, you know, the offset. Oh yeah, the offset also changes. The offset, it's will also change depending on the size. You know, that angle it's a flexible angle. So when I move that, I think the offset changes. No, the offsets remain fixed. I'm going to change this to 6 inches instead of 4. No, 4 inches is fine. You can always change it in the context of the project. And this is my panel. All right, I'm going to save this file as a family. Let me put it in my docs, my desktop. I'm going to call it panel, special panel. And then this panel is going to brought into Revit, into our Revit project. So I'm going to file, new project. I use the architectural template. Then I'm going to load this family into the project. I just jump into the family and I say load into the project and close the family. That make it visible. If I scroll down into the project browser under the families, under curtain wall panels, there's the special panel is here. And now let's create a curtain wall. So I'm going to do architectural curtain wall. And I'm going to use this storefront method. I see it in 3D here. And now I wanted the vertical ones. I don't want to have these extra panels, residual panels. So in order to do that, I need to change in the properties of this curtain wall. You know, I'm going to duplicate it and call it, this is the special storefront. And instead, the vertical grid, the horizontal grid, instead of being fixed distance, I'm going to say that maximum spacing 8. and then hit OK. There you go. And then it's not going to have any residual panel anymore. The other thing I'm going to do is I'm going to remove all the mullions. So no mullions for this one. So just change this to none. Revit is going to give me the warning that mullions are going to be removed. So you delete them. And then the final step is to bring that family, associate the storefront with the family. So you go edit type, and when it says curtain wall panel, instead of the glaze one, I select my special panel. And here you go. Here is my nice waved panel that I use via a custom curtain wall. Then you can go into one of them via tab select. You can say, okay, what's the material that you need? Edit the type properties, and you can say, make this glass or metal, aluminum. I'm going to search by keyword, and that's going to apply a material to those curtain wall panels. Okay, apply, okay, here you go. And this is all subject to the rules of the spacing. So the layouts can be changed, and this is going to react automatically. But I want the spacing to be I don't know, 10 feet, and the spacing here also 6, and the whole thing rearrange. So do you guys follow? Any question? And just like I did that example, I think we could do other examples. The project I was showing you earlier is an example where you can use in very unique ways of creating custom curtain panels that represent other type of conditions. I think I show you guys this one, but the one like this panel, for example, I want to tab select. This is a panel. I'm going to edit the family. And this is a panel that display a solid spandrel. This spandrel is actually a sweep. It's a profile that is extruded along a path. And then this guy is just a simple extrusion that has a start and a beginning. And then these in the views, the whole thing has a single parameter called the spandrel height. It's a type parameter. So in the context of a project, you can select the panel properties and change them. Say, I go to the type property here and say the spandrel height, it needs to be 3 feet. And that's going to apply, I change it to all of them. Or 2 feet, etc. So you can use this technique to create like patterns using modular a modular display. Let me show you another example. This is This is the spandrel with brackets. So in the curtain wall properties of this, select it first. I have to go to the 3D view. This panel here, you tap select. It's called glaze panel with a spider. When you look at the type properties, you can change some parameters like the thickness, the spider offset, the material. And this is what I was saying, that all the parameters need to be, all the materials need to be defined in the project. Let me open this family. This is how the family looks like. These spiders have been downloaded from the manufacturer. It's a quad connector 3615. And it's positioned precisely at a point in which it can span between multiple panels. It has also these shade devices, which is a Conair sunshade. This was downloaded from the website. But it has an associate parameter. Look at this, is a visibility toggle that is connected via the associate parameter with this sunshade option. And so when I go back to the project and I tap select these guys, these as an edit parameter, I have the lower spide, the sunshade, and the upper spider as type parameter. And somebody asked me what was a type parameter. If I enable the sunshade here, it's going to change them to all of the panels that are the same type. You can disable the visibility of that. You can display the upper spider. So there's an upper and a lower spider. And then the upper spider should appear. There you go. And so you can start like building these pixels, all these pieces like it was a puzzle. And you can individually swap some panels to close the loop, because if you repeat this pattern, there's going to be at the end maybe a residual panel that needs to display a different configuration, but you can create a different type for that and swap the panel as needed. And I think these other examples, I did not want to do this in class because it was going to take a lot of time, but it's an array that is driven by that defines the number of slats. Number of slats is an instance parameter. So you can define how many slats you have in a louver. And then you can also define the finishes, the materials, and the frame width and depth. Let's say I'm going to increase the frame width to 4. There you go. And frame depth to 4 as well. And those are instance parameters, so each of them can have a different number of slats. You can, if you model this with a greater precision, you can also change the angle a bit. Let me just show you how this was built, just as a description. When I added this family and when I switch it to 3D, This is a slat array. It's a nested family. So a nested family is a family inside a family. So if I add the family, I have access to this nested family. And then this nested family is an array. When I look at it in elevation, then the array is connected with a parameter called number of slats. And so this is an instance parameter. And as an instance parameter, here it is. You can change the number of slats, which in turn changes the number of elements in the project. And then if I dig deeper, this is an array of a slat. But if I edit the group and I selected the slat, here's the slat, it's a nested family. So I edit the family. And this is a single slat in an angle. And this slat is an extrusion with a specific dimension, and it's concatenated via associate parameter. And so I have 3 levels of nested parameter. This slat is nested into the model array. It's arrayed into this curtain wall family, into this generic model family, and then this generic model family is nested in turn into the curtain wall panel, and then this curtain wall panel is nested into the curtain wall definition. Okay, so I hope this was useful, and I hope you were able to follow along. You can be very creative as far as the kind of things that you can do with this. And you don't have to be like a computational designer to do this in Rhino, as long as you can put a little effort on how to do this using just curtain walls. Okay, it's 7:15. Any question? All right, next class, we are going to do the railings, which I want to start with this one because it was the easy one. The railing is going to be a little long, so yeah, we're going to take probably the entire class next one. Jocelyn created a custom railing. Oh, I wanted to, I don't know if you guys were able to watch the webinar about Twinmotion. I don't know if you guys are familiar with Twinmotion, but one of the things in Revit 2024 is that Revit ships with Twinmotion. And it's not in the agenda to talk about Twinmotion, but I figured I'd just mention it because it's a new thing. And Twinmotion, it's a tool that was developed by Epic Games, a game engine, game developers. And it's used by a lot of different firms to create this type of visual representation. This is an example of the new vice presidential palace in Indonesia. And it was created in Revit and then rendered in Twinmotion with this new connection between Revit and Twinmotion. So Revit 2024 comes already integrated with Twinmotion, and it creates this level of photorealism that is far superior from the out-of-the-box capabilities. And it's been announced. This is nothing new. This was announced in November last year. but this is the type of high photorealistic rendering that you can achieve with Twinmotion. This is a project in El Salvador. Actually, in the project in the house where I grew up, is now becoming a apartment towers. And the design team was using Twinmotion to generate VR experiences. These VR experiences, this is a house and an apartment with multiple design options in Revit. It was a single apartment with 4 different design options. They were created for different market segments. A drone took a 360-degree panorama. That's the San Salvador volcano. This is the place of the project. To have a real assessment on what the view was going to be from the apartment balconies. And then the customers were given headsets where they can swap materials on the fly with their limited palette of available choices. And they could experience the product as if they were in real life using an Oculus headset or an HTC Vive. And so these design options render in the Twinmotion. They're all coming from a single Revit file. That view that you have from the balcony was actually a 360-degree capture from the location at 7 p.m. at night. So it was, there's nothing to pay upfront for Twinmotion. It ships with Revit, and take advantage of it in Revit 2023. So if you go to the View tab, Twinmotion is right here, and it creates a direct link with Twinmotion where you can render the scene without paying an extra cost for a third party add-in. I think most people nowadays use Enscape or they use V-Ray, but now Twinmotion comes with Revit starting in this release. Okay, it's almost 7:20. Any question, guys? All righty. Then let's meet next Monday. Have a great weekend.
Thank you.
Thank you.
Okay, thanks.
And Lindsay, do you want to stay?
Yeah.
On that issue?
Yeah.
Want to stop the recording?